In the vast ocean, modern ships quietly cut through the waves and head out to sea, where schools of tuna surround the warm ocean currents. This is an ideal destination for tuna trawling, a method that requires both modern technology and the coordination of the entire crew. Each trip is a battle between humans and the ocean, between mechanical power and the cunning of tuna, which is famous for its speed, alertness and strong swimming ability. The process of catching tuna by trawling begins with determining the location of the school of fish. On board, modern positioning devices such as sonar, long-range radar, GPS satellites and sonar fish detection systems are continuously operated to determine the exact coordinates of the tuna moving in the deep water. The captain and his team of observers monitor data from the control screens and signals from helicopters or drones flying overhead for signs of fish, small ripples, silver flashes, or flocks of seabirds circling the water. Once a school of tuna is identified, the captain steers the ship to a suitable location to deploy the trawl. The modern trawl system is a purse seine, a large net that can be hundreds of meters long and tens of meters deep. Designed to encircle the school of fish and seal the bottom, the mothership and the small auxiliary ship are deployed. The auxiliary pulls the net around the school of fish while the mothership adjusts its course to create a perfect seal. Once the net has completely encircled the school of fish, a bottom locking system is activated to prevent the fish from escaping below. The tuna are now completely surrounded in a giant water bag made of super strong nylon. Retrieving the net is a process that requires close coordination and carefulness. Powerful electric winches begin to reel in the nets, while hydraulic cranes and high-pressure water pumps gather the fish to one side. The tuna are sucked up onto the deck through special pipes or scooped up by giant crane buckets. Here, a specially designed sorting and cooling line awaits the catch. The tuna are weighed, sorted by size and meat quality. And then placed in -60 degrees Celsius cold storage or super fast freezes to maintain maximum freshness. On board, every process is strictly monitored by a system of sensors and surveillance cameras. A central computer records data on each catch location, fuel consumption, electricity consumption, net depth, current speed, and even sea weather. This not only helps optimize fishing efficiency but also serves the purpose of tracing the origin of the product later, ensuring the sustainability standards that the international market is increasingly demanding. However, tuna fishing with trawls also has many potential challenges and risks. Due to the large size of the purse seine, the risk of catching juvenile fish, non-target fish, even sea turtles and dolphins still exists. To minimize the impact on the ecosystem, many modern fishing vessels have installed whale and dolphin repelling devices, used nets with appropriate mesh sizes, and strictly complied with the regulations on prohibited fishing areas. Seasons and production quotas set by international organizations. After many hours of non-stop work, when the refrigerated compartments were full of tuna, the modern ship quietly turned its bow back to port. On deck, the crew took a break to the hum of machinery and the gentle waves. They know that behind each tuna caught is not only high economic value but also sweat, technological intelligence, and the enduring spirit of people who live their lives with the sea. Tuna trawling on modern vessels is no longer a simple hunt, but has become a symbol of the evolution of fisheries in the era of technology and sustainability. With the development of technology, Modern tuna boats are not only fishing vessels but also mobile processing factories at sea. On many large ships, fish processing systems have been integrated on site. After being brought on board, the tuna will be transferred to the processing area, where the team of workers quickly performs the gutting, removing the organs and washing with cold seawater. Some ships also have vacuum chambers and automatic packaging machines to preserve the tuna in sterile packaging, serving direct export to the Japanese, European or American markets, places with extremely strict inspection standards. Another notable point is the application of artificial intelligence, AI, and automation systems in the operation of modern tuna boats. These systems are capable of analyzing real-time data, predicting the path of fish schools, controlling engine performance, and even giving early warnings when problems occur in the engine room or when the ship enters dangerous waters. This not only helps increase production efficiency but also ensures human safety and minimizes environmental risks. However, the trip is not always smooth. The open sea always has unpredictable surprises, storms, unusual ocean currents, technical problems, or simply a school of tuna suddenly changing its migration direction. At that time, the captain's courage, the solidarity and experience of the crew become decisive factors. Many times, they have to work continuously 20 to 24 hours a day, in strong winds and high waves, while the whole ship's hull shakes violently. A small mistake in the process of net collection or adjusting the wind direction can also cause the entire catch to be lost or damage equipment worth tens of thousands of dollars. Along with the challenge comes pride. Oceanic tuna, especially species such as bluefin tuna, big-eye tuna or striped tuna, have extremely high economic value. A special type of bluefin tuna can be auctioned for tens of thousands, even hundreds of thousands of dollars at famous fish markets such as Tsukiji in Tokyo. That is a worthy reward for the hard days drifting in the open sea, and is the motivation for sailors to continue to stick to the sea and stick with the job. In addition, the issue of protecting aquatic resources is also being put on top. International fishing organizations such as ICCAT, Commission for the Conservation of Atlantic Tunas, or WCPFC, Western and Central Pacific Tuna Commission, have issued many regulations that fishing vessels must comply with, from installing satellite positioning devices, reporting production online, not catching young fish, to keeping electronic logs of operations. These regulations, though strict, are necessary barriers to protect the ecological balance and ensure fish resources for future generations. Today, tuna trawling is no longer simply a labor-intensive industry as it once was. It is gradually transforming into a high-tech marine industry, combining knowledge of marine biology, maritime engineering, automation and global economics. Modern ships with corrosion-resistant alloy hulls, automated control cabins, long-range radar systems and satellite communication stations are living proof of the great progress of the maritime industry in the 21st century. When the ships dock after weeks at sea, the frozen containers filled with tuna are brought ashore. preparing for another journey, from the seaport to the factory, from the factory to the fish market, and from the fish market to the luxury dining tables around the world. Few people imagine that to get each piece of fresh, sweet, fatty red tuna, there is a series of arduous labors in the vast ocean. It is not only a story of technology or profit, but also a story of people, of will, of the enduring attachment between fishermen and the ocean, a sacred relationship. Both harsh and glorious, not only stopping at fishing. On each voyage, the crew must also take on the role of order and biosecurity keepers. Before each net drop, they must carefully check the condition of the equipment, closely monitor warnings about prohibited species or risks of damage to the marine environment. Many vessels have been equipped with biological classification devices during the net collection process, allowing timely release of species not on the catch list. This not only minimizes damage to the ecosystem but also helps avoid legal problems in seafood export activities. Some modern fishing vessels also implement the model of survey and fishing vessels, which means that they both fish and collect data on the distribution, quantity, and spawning season of tuna, while measuring environmental factors such as water temperature, salinity, depth, and pollution levels. This data is then shared with international oceanographic research centers, contributing to research and conservation programs for marine resources. Thanks to that, exploitation activities not only serve the economy but are also closely linked to the task of sustainable development. In addition, life on board is also a separate world. During weeks, even months at sea, crew members must adapt to a closed environment, lacking phone and internet signals, completely isolated from the mainland. To maintain morale and health, modern ships are often equipped with additional amenities such as clean bunk beds, cooking areas with full frozen foods, and even small gyms and TV screens for after-work entertainment. Team spirit is the key factor that helps them overcome the long, stormy days, when just one person losing his temper can affect the whole group. Many sailors are people who have been involved in fishing all their lives, passing on their experiences from their fathers, but there are also many young people who have graduated from maritime universities, marine engineers, and even information technology specialists who are recruited to operate navigation software and automation systems. This shows the strong transformation of the maritime profession, no longer simply manual labor but a combination of tradition and modern knowledge. After each trip, tuna is brought to the port and quickly distributed to processing centers. Here, the fish is filleted, smoked, canned or processed into sashimi depending on market demand. Grade 1 tuna can be auctioned directly or exported directly to Japan, where a piece of bright red fish meat can fetch hundreds of dollars per kilogram. Lower-end products are sent to processing plants to be turned into canned fish, fish sausages, fish oil or animal feed. The life cycle of a tuna, from swimming in the deep sea to appearing on the dinner plate, is a long journey. And trawling is an important starting point for that journey. Behind the full catch are thousands of hours of non-stop work, techniques, discipline and silent sacrifices of modern fishermen. They are not only workers, but also the first link in the global seafood supply chain, playing an important role in maintaining food security and developing the marine economy of many countries. In the context of climate change and overexploitation seriously threatening ocean resources, Modern tuna trawling is gradually shifting to a more environmentally friendly direction. Innovations such as smart nets that remove juveniles, marine life monitoring devices, software that tracks sustainable fishing areas, etc. are being widely deployed. Many fishing companies have achieved MSC certification. An international standard for sustainable fishing, helping their products gain higher value and be accepted in demanding markets. The future of tuna trawling is being drawn by technology, responsibility and innovation. When people know how to balance exploitation and conservation, between economic benefits and ecological ethics, fishing boats will continue to cut the waves, go further, smarter and more efficiently, on the vast ocean. That journey will continue, like a lasting epic between humans and the sea, both majestic and long-lasting. Along with the development of the modern tuna trawling industry, there have been profound changes in international management and legal policies. In the context of global tuna stocks showing signs of decline due to overfishing, many countries and international organizations have introduced strict control measures. Modern fishing vessels wishing to operate legally must register for licenses, comply with production quotas, declare details of each trip, and be subject to 24/7 satellite monitoring. Failure to comply can result in being banned from entering ports, being refused import, or being excluded from the global supply chain, something no business wants to face. Not only state organizations, many international processing companies and supermarket chains also require tuna to be caught according to sustainable processes, with clear and transparent traceability, even requiring vessels to have independent observers to monitor the entire process from dropping the net to harvesting the fish. This makes fishing vessels not only a place of work, but also a space that strictly adheres to international standards, from human rights, occupational safety, to marine life protection and data transparency. Another aspect that cannot be ignored is the growing role of digital data in tuna trawling. Data on tuna migration, water temperature, air pressure, current changes, plankton density, etc. are all collected and analyzed by machine learning algorithms. These systems are capable of suggesting the most likely drop locations to capture the optimal catch while minimizing off-target fishing. Thanks to this, a fishing trip can save thousands of liters of fuel, shorten the time at sea and reduce greenhouse gas emissions, a big step forward in the effort to reduce the impact on the ocean environment. However, it cannot be denied that behind the flashy technological facade, tuna fishing is still a hard job, requiring good health and a strong spirit. The days when the ship drifts in the middle of the deserted sea, where the sky and water become one, where loneliness and pressure are present every minute, are real challenges for anyone in the profession. Every night of staying up to collect the net, every long shift under the scorching sun or pouring rain, are all proof of the resilient will of those who stick to the sea. And then when the ship turns the waves to return, docking at the port in the golden afternoon light, the atmosphere on the deck seems to explode. The crates of frozen tuna are full. The faces are radiant and exhausted, the result of thousands of hours of tireless work. The fishing port becomes bustling, With refrigerated trucks, forklifts, ship whistles, bustling transactions and the distinctive smell of sea fish permeating the air. That is the moment when fishermen feel the true results, not only the material value but also the pride of conquering the ocean with their own efforts and intelligence. Today, tuna is not only a nutritious food source but also a symbol of the marine economy, of international trade integration and of the sustainable preservation of the ocean. Each tuna brought into the global supply chain is the crystallization of a series of factors: advanced technology, smart management policies, international cooperation and especially the silent sacrifice of people working silently day and night at sea. Tuna fishing with trawls on modern ships, therefore, is no longer a backward traditional profession. It has become a new symbol of the connection between people and nature, between tradition and technology. Between economy and social responsibility. Amidst the many challenges that the ocean brings, the journey of tuna fishing boats continues without stopping, an epic of courage, innovation and belief in the blue future of the sea in the near future. Tuna trawling will continue to transform dramatically under the influence of the 4.0 industrial revolution and the trend of globalization of the food supply chain. On many modern vessels, artificial intelligence systems not only support the location of fish schools but also have the ability to automatically optimize routes, adjust the speed of releasing and retrieving nets, analyze the weather, predict yields in real time, and provide early warning of risks such as equipment failure, changes in currents, or even the risk of collision with large creatures such as whales. These technologies, when combined with satellite data and ocean temperature maps, help fishermen no longer have to fish blind, as before, but can act faster, more accurately, and more effectively than ever.